I would like to cover the features of the quantitation method editor. Now, as always, the best way is to look at the application. I'm going to cover a little bit of the same ground by creating a new batch. I'll call it my new batch. And then I'll just add all the samples that are in that directory already. What I'd like to demonstrate to you here is the ability to create the quantitation method from the acquisition method. So I'm looking at the method menu here, and I'm going to create a new method. I have a couple of different ways. I obviously could type in the method, and we'll call that manual method setup. I can also use a data file that exists in that batch, or any other batch for that matter, and I can take the acquisition method that exists with that data file and create a quantitation method. So let me go through that. I will take this particular sample, which will send me over to the method editor. And what I've got right now is I have pulled in the compound names, which are assigned when I did acquisition. And you'll see that for each of these compounds in drugs of abuse, it has pulled out the transition for those compounds, precursor ion and product ion. If I drop down the Explorer bar on the left, I can see different aspects. For example, I can see the MRM transitions that I just mentioned for the target and the ISTD. I can look at the retention times, which have been picked up from the acquisition method as well, taking the signal and pulling out the retention time using the default window. I can see the ISTD setup. Now, I need to assign the relationship between the target and the ISTD in this table right here. That's pretty straightforward because the amphetamine has a ISTD of the deuterated compounds. I'm just going to do that right here. I'm going to assign for each target its deuterated ISTD, MDMA, and then methamphetamine. All right, the next is the concentration setup. Now we're in the concentration setup. Let me point out that you will see the signals in the graphics at the bottom. If your transitions are correct, it will extract that sample and you'll see the signals, both the target and the qualifier, same as you see at batch at a glance. In fact, here's the spectrum of the precursor and its product ions. So I'm back to the concentration setup. And what I'm going to do here is use the dilution assistant, which is the toolbar up here. So I know that the highest concentration for this particular sample, this particular compound, is 125. I also know that I used quite an elaborate dilution pattern of 1 to 5 to 2 to 2.5 to 2. There are other choices that are simpler than that, but that's the one that I used to create this calibration curve. If I go up to the assistant, I'm going to put L as a prefix to the level names, and I also will tell it that there's 5 levels. Now I will create those levels, and you'll see that I've got the levels created for amphetamine. Now notice that I only have the calibration curve set up for amphetamine, but not the other compounds. So what I'm going to do now is use a capability of the method editor to copy those calibration levels over to the other compounds. Here are the other compounds. I can collect them to one compound or a set of compounds. That might be useful if I had multiple dilution patterns that I was using within one batch. But I will, in this case, there's only one dilution pattern, so I will copy it to the rest of the compounds, as you see here. The next step would be the qualifier setup. Now the automation of the quantitation method has picked the strongest signal for the target compound, and here's an amphetamine, and then has taken the next strongest signal from the MRM transition and assigned it to be the first qualifier. And I'm happy with those choices, so I'm going to stick with them. And last, the calibration curve setup, the default being linear, ignore, and none. And I think as you saw in the calibration curve fit assistant, the manipulation of the curve fit, so I'll leave that as an exercise that happens when you're back in batch at a glance looking at the calibration curve. Now that I've made all the assignments in the method, let me just go and restore the default layout so I get to see the signals. And I will inspect each of the compounds to make sure that there's a signal with the transitions that I put in. And once I've done that, I'll take a quick look at the global setup, which is typically works by default. I've got apply multiplier to target and apply multiplier to surrogate in case I were to do some dilution of samples. The others typically work by default. I will now validate, and I see that there are no errors. If there were errors, I would see them in the list here and it would point me to where to correct it. So I will exit the method editor and then apply this method back to the batch. And I'll see I'm back in batch at a glance. And the next logical step would be to run that method against all the samples. And you'll see that it's cranking through the samples right now. And I should see the calibration curve appear right over here. And the signals appear over here for any particular sample. So I've got a valid method that I've created from scratch using the acquisition method for this batch.